When working with complex features in SolidWorks, it always pays off to know many ways to accomplish the same geometric goal. This is why when developing a strategy for modeling a part, I identify a group of features that can be used to create each face. The blend between the handle top and the main body can be made using the loft or boundary surface feature. It turns out that on this part, for whatever reason, the loft feature will not allow me to create curvature continuous condition at the ends of the loft. It frequently happens that things don't work out exactly the way you envision they should. For this reason, it's always a good idea to try to have alternative methods available to you. These are not necessarily bugs in the software. In fact, there's often a good reason why things don't work, even if the reason is not obvious. Since the loft will not perform the way I need it to on this part, I'll instead use the boundary surface feature. I'll initiate the boundary surface, and in the Property Manager, I'll select the trimmed edge of the handle in the Direction 1 selection box. Then I'll right-click and activate the Selection Manager to make the selection from the large hole trimmed in the main body. The Selection Manager is necessary because the hole is made up of multiple edges. Now I'll set the tangent type at each boundary to Curvature to Face. Notice that with the boundary surface, you must select the boundary in the selection box, and then set the tangent type below in the drop-down. To set the second boundary, select it from the selection box, and the value in the tangent type drop-down box changes. This is different from the loft interface where each end profile has a separate drop-down box for the tangent type. Depending on how the edges were selected, the boundary surface may be twisting somewhat. If so, the connectors shown at the top of the surface need to be adjusted to straighten out the mesh on the surface. A twisted mesh can result in folds or kinks in the finished surface. The lines are there to show the underlying structure of the face. Note that connectors are not displayed when using the Selection Manager. If the connectors are not displayed, be sure to close the Selection Manager. Also, be aware that in the SolidWorks help documentation, connectors may also be referred to as handles, and the method may be called synchronization. Connectors in a boundary surface work just like the connectors in a loft. If they're not displayed, right-click in Space and select Show All Connectors. Additional connectors can also be added to control the mesh in specific areas. Notice that the connectors also have arrows which allow you to control the stiffness of the tangency from that edge. The arrows have an analogous function to the arrows on spline handles. At this point, I'll click OK to complete the boundary surface. To check the quality of the transition across the edge, I'll use the Deviation Analysis tool from the Tools drop-down menu. The deviation is the angular difference from perfect tangent. In order for this to work, the faces on either side of the edge must be knit. Otherwise, you'll get the error message, "Laminar edges cannot be evaluated." Laminar edges are simply edges that are directly on top of one another which belong to separate bodies. Once bodies are knit or merged together, there's only a single edge between faces. In this case, the maximum deviation is 0.01 degrees, which is acceptable. I'll delete the knit surface since we'll be knitting all surfaces together later in the process.